Chapter 9, Water Resources, Video 4, Increasing Water Resources. There are several ways to address the water shortages facing much of the United States and other parts of the world. You can increase efficiency of use, recycle by reuse, and substitution by using salt water. In addition, other approaches include extending the dam and reservoir system and canals and pipelines that can store water between areas. That way you can connect areas that are rich in water to areas that are not. Water efficiency. Water resources provide many opportunities for conservation. Micro-irrigation for agriculture that can reduce evaporation. Individual lifestyle conservation such as shorter showers, not letting the water run, low flush toilets, and landscaping that includes the low use of water, such as you find in Arizona, xeriscaping. And then also wastewater reclamation, closed loop reclamation, and gray water use. All can increase efficiency. In a desalination plant, water is heated, usually, or filtered, and then condensed. As the salt water is heated, the fresh water leaves as steam and then is trapped in a cold coil, which then produces fresh, drinkable water. That hot water then passes through a series of tanks, siphoning off the distilled water for drinking and flushing the heavily salt-concentrated water back into the ocean. This classic form is very high cost because water can absorb an enormous amount of energy. £200 per 1,000 gallons of water must be removed before you can drink it. Membrane and distillation methods are still the most frequent, but the membrane is much more cost efficient than distillation, which requires large amounts of fossil fuel. Claiming wastewater or reclaiming wastewater is a newer technology, one used in deserts and dry areas of California. Technically, wastewater can be safe to drink if it's treated properly, but most wastewater reclamation is used as gray water, used for agriculture or watering needs other than drinking. It's also much cheaper to treat wastewater than to desalinate salt water, due to the high specific heat of water in general. Dams and reservoirs and canals redistribute water from water surplus areas to low population to water deficit areas and high populations. Indeed, this is how most of the drinking water in California urban areas on the coast is moved or transported. Water from high areas with high snowpack is obtained during the snowmelt in the spring and then rationed downstream to Los Angeles and San Francisco. Dams can also be built to minimize flood damage through flow control, but their primary purpose is to create a storage reservoir and perhaps provide some hydroelectric power. As we discussed in previous chapter, even well-designed dams have several environmental problems, such as sediment accumulation, downstream scouring, depending on how release is mediated, lots of evaporative loss, salinization from evaporation, and then sometimes catastrophes from breaks. This is a picture that shows the bathtub ring in Lake Mead, an area where there's higher use than replenishment. The Lake Mead Dam, the dam that holds Lake Mead, originally held water at this mark here. Over the last 20 or so years, when use has increased and drought has taken over, you can see where the water's been bleached, the rock has been bleached, was a good 30 feet over the top of this boat. So from here to here is probably about 50 or 60 feet tall. or a 5-story building. That's how much water is in depletion from the last 20 years. Canals, also known as aqueducts, are artificial channels built to transfer water over long distances. In Arizona, canals fill a lot of the area around Phoenix. Excuse me. And transport most of the water from either underground sources or from dams up in the mountains. There's also a lot of evaporation here, but they've been very successful. There are other solutions to water scarcity besides engineering. Historically, the low cost of water has offered little incentive to conserve the resource. That is changing rapidly. Stopping subsidized water for agriculture will let market forces assist in conservation. Right now, water rights are sold for free and people can pump as much up as they can afford in order to do agriculture. If that water becomes a priced resource, then things will have to change, including agricultural practices. Effluent charges can promote industrial and household water efficiency as well. In Maine, if you're hooked up to municipal water, it costs more for the water that you flush than the water that you take in. You charge more per amount. They determine that amount by how much comes into your house at a certain rate of cost, and then charge you more for the rate that they assume is coming out the other end. Oops, sorry. We can also conserve water through the primary types of conservation we've talked about previously. There's recycling of wastewater, substitution of other liquids or sources or other liquids in processes. And we can also use it in a more efficient way, such as low flush toilets or low use shower heads. By reducing the input, we lower the throughput as well and reduce our waste stream. Because all of these issues are society issues, you can also attach legal motivations or restrictions on water use. Legal restrictions shape water use, but they're often less effective than non-legal ones. Some of the more common ones are laws that govern the use of river waterways and that's called riparian water law. And in Maine, there is riparian water law, but it's much more common to have very intense riparian water law around urban areas where the use or non-use of areas around the rivers is highly regulated. You can also have appropriation water law that dictates who can take what and when. Market conditions may provide a better allocation system because it tends to distribute costs more equitably and is often the only practical way of controlling water use. Legal solutions are usually used only when there are fewer parties involved, a source is easy to monitor, or a resource is in very short supply. Regulations must be strict and they're expensive to enforce, whereas market conditions are automatically felt across the society. If you attach costs to water use, then people will change their behavior. So in this end of this chapter, we talk about the 4 ways to increase water resources, how to improve water efficiency. We talk about the property of water that makes desalinization so expansive, i.e. high specific heat or high heat capacity. We talk about why wastewater reclamation has not been so successful. Well, we don't really talk about that, but you can figure it out. How many people would be happy drinking water that came out of a sewage treatment plant? What are the drawbacks from creating new reservoirs and dams? And what are some of the social solutions and economic solutions, as well as legal solutions?